Hello friends, and welcome to another lecture on operation research. We will look into a transportation problem and we will solve this problem using least cost method or the lowest cost entry method. Well, it is best explained using an example. So the example is on your screen. A dairy farm has 3 plants located in a state. Daily milk production at each plant are Plant 1, 6 million liters, Plant 2, 14 million liters, and Plant 3, 4 million liters. The daily demand it should be from the distribution centers are distribution center number 1, 10 million liters, distribution center number 2, 5 million liters, distribution center number 3, 7 million liters, and distribution center number 4, 2 million liters. The cost of transporting milk to various distribution centers from plant to the distribution center, of course, is given in the table. The cost is in multiple of 1000 rupee per million liter. So let's say if you want to transport milk for plant number 1 to distribution center number 3, you will have to pay 11,000 rupees per million liter. Let's say if you want to transport milk from plant number 3 to distribution center number 2, you will have to pay 8,000 rupees per million liters. Now, how do we allocate the capacity that we have to the distribution centers in an optimal manner? Or I start with what can be an initial feasible solution to this problem? Well, all the allocation is done to all the demands. Now, how do we go about it? Using the least cost method. For this, we copy down this table that we have, and I have already done it for you, and we write it down this way, where what we do is we add one column on the right and one row in the bottom. In the column that is in the right, we write the supply from the plants, and in the bottom row, we write the demand that is from the distribution centers. So let's do that now. Now from the supply side, what do we have is we have 6 million liters from plant number 1, 14 million liters from plant number 2, and 4 million liters from plant number 3. On the demand side, of course, we have the demand in distribution center number 1 is 10. The demand in distribution center number 2 is 5. Distribution center number 3 is 7. And distribution center number 4 is, let's check it out. 2. So there we are. Let's rub this off. Now the allocation is done using the principle that you have to find what is the least cost of transport in this entire matrix and allocate the supply to that cell. Now what do we find here? There are 2 entries, that is in cell number 2(1) and in cell number 2(4), where the cost is least and it is 1. So that is a tie. In case of a tie, what do you do? In case of a tie, you see which cell has the maximum demand. Now here, the maximum demand is in cell number 2(1), that is distribution center number 1, supply from plant 2 to distribution center number 1, and that is 10. So what we do is we allocate 10 million liters to cell number 2(1), that is to distribution center number 1. So the leftover is going to now be 4 million liters from plant number 2, right? Now again, what we do now is we strike distribution center number 1 because its demand has already been met. Now its demand is 0. Now what we do is we have center numbers 2, 3 and 4. And now in this matrix, we see what is the minimum cost. And of course, the minimum cost is 1. That is supply from plant number 2 to distribution center number 4. It's but natural, since this cost is least, we supply 2 million liters to distribution center number 4. So 2 is left over. And now we strike down distribution center number 4. The reason is its demands have been satisfied. Now we are left with a matrix where we have distribution center number 2, 3. And of course, we have supply from plant number 1 and also remaining supply from plant number 2 and supply from plant number 3. Now here what we do is we check the matrix of distribution 2, centers 2, 3 and plant number 1, 2, 3 and check which is the least cost. Now the least cost here is 3. Okay. And the demand is 5. So what we do is we allocate this demand of 5 million liters and we cross it off, since now the demand for distribution center number 2 has been met. What is left now is 1 million liters that needs to be adjusted to some distribution center. That is, in this case, it's distribution center number 3 itself. Okay, from plant number 1. Now let's go about it. Now, since the position of the cells are fixed, that is position of cell 1, 3, cell 2, 3 and cell 3, it's fixed. We can't change. So what we are left with is this 1 million liter is now going to be assigned here. 2 million liters is going to be assigned here and 4 million liters is going to be assigned here. Okay, so we are done. Now let's calculate what is going to be the cost for this distribution. Now let's do that. So the cost is now going to be rupees 1000 into 1 into 10 plus 3 into 5 plus 11 into 1 plus, what I am doing is just multiplying the cost with the allocation. 6 into 2 plus 15 into 4 plus 1 into 2. So that's going to be rupees 1000 into. So let's call up our calculator. Delete all that we have. Okay. So that's going to be now, yes. 1 into 10 makes it 10 plus 3 into 5 makes it 15 plus 11 into 1 makes it 11 plus 6 into 2 makes it 12 plus 15 into 4 makes it 60 plus 1 into 2 makes it 2. So there we are, 110. So the cost is now going to be rupees 110,000. That's going to be the cost. Now, interestingly, if you see that with the northwest corner method, the cost comes to rupees 114,000. Now, this is lesser. Okay. The cost that we have calculated now is lesser than the northwest corner method. And this should be. That is because here we have chosen the cells which have the least cost. But in northwest corner, we do not do any such activity or any such allocation. We just go by the rule that whichever is the northwest corner, we start with that. Whether its cost is high or low, we do not bother about it. Okay, so it's bound to be lesser. Now, does this give an optimized cost with respect to the northwest corner method? Yes, it does give. So it's a good idea to use the least cost method. But northwest corner has its own advantages that you need not bother about the cost, and you get an initial feasible solution, and then of course you can optimize it further. But this goes one step further and does some initial optimization of the costs. Now, is this a feasible solution? Well, for a feasible solution, the condition is that n plus m minus 1, that is number of rows, that is 3, plus number of columns, that is 4 minus 1, which is 6. Your allocations should be equal to m plus n minus 1. Now we have 6 allocations here, and of course m plus n minus 1 is also 6. So this is a feasible solution, and this is also known as a non-degenerate feasible solution. If the number of allocations is lesser than m plus n minus 1, then we call it a degenerate solution. But this is a non-degenerate feasible solution. So that was all about how do we solve the problem using least cost method or the lowest cost entry method. Hope you have gained something from this lecture, and I'm sure about it. So if you like this lecture, give it a thumbs up, and of course do subscribe my channel. I will be taking up the entire course of operation research and producing videos on it. So if you want to really learn operation research, welcome to my channel. Okay guys, have a great day.